Okay, we are going to go over 1.1, 1.12, 1.13, and 1.14. So this lesson is about transformations, and basically what a transformation is, we take a function, f of x, and we do something to it, and then we end up with a new function. Okay, so that's basically all it is. We're multiplying, dividing, adding, subtracting to move these values around. So these are the main transformations. Remember, this everything's an input and output, but f of x, like when you put the input in, you get the output, and the output is the y. Okay, so if you add some number, that means the y is going up. That's why it's a vertical translation. If it was minus k, then the y would go down. So anything with vertical, they're talking about y's. So let's talk about the other vertical. So in this case, it's a times the y. So the y is going, it's a dilation by a factor of a. And you'll take the absolute value of that. If there was a negative out here, we talk about it here at the bottom down there, but if there's a negative, that's a flip over the x-axis. So that's something to keep note. You don't. This is a vertical dilation. Now let's talk about horizontal. So horizontal means that the horizontal has to do with the x's. So vertical is the y's, this is the x's. So if you put something inside the parentheses, it always goes opposite what you would do. So that's why this is a horizontal translation. Translation just means you're moving the graph. The graph shifts. And it's 8. See how this is a plus? If this is a plus, then it goes minus. Okay. Now, if you put this in, this is going to affect the x. This is probably the most tricky one. When you put, when you have a f of, when you put something inside the parentheses, it goes opposite of what you think. So instead of multiplying, the dilation is going to be 1 over a. Okay, and you're going to see multiple examples of that too. And then it also means if there's a negative in here, that has a different, a negative would mean something different too, which they talk about right here. So if you put a negative here, this flips over x. The point. Technically, it's the y, because if you flip over like if you're here and you flip over the y. I mean, that's not a good example because that's not a perfect flip, but that's a flip and a vertical dilation. But if you put a negative in front of here, it's a reflect over the y. And we'll get practice at that. So, okay, so we did this one in class, but in this case, we just want to transcribe we want to describe the transformation. So remember, this is a function. This is a function. Okay, these are the transformations. Or let me be a little bit more specific. This is also a function. Okay? So, you always want to look inside this parenthesis right here. Let me make this smaller. You always want to look inside that parenthesis. That determines what's happening with the x. So, on paper, you would say a horizontal dilation of 1/2. Okay? What that means in real words is all x's are a half. Okay, so all x's are like a half of what they were. Okay, that's the first thing. Now if we look at the 4, don't look at the minus, I'm looking at the 4. So the 4 would be a vertical dilation of, a factor of, it's going to say a factor of a factor of 4. So that means all the y's are now going to be 4 times what they were. So the y's are times by 4. Now we'll take care of the negative. What the negative does, it reflects, the y reflects over the x-axis. So on paper, you'd want to write that, you'd want to write that, and you'd want to write that. So this would be an example, okay? Now, this is the graph. This is f of x, okay? So that's a function. That's a function. But g of x is another function that has 2 transformations to f. So if you do 2 transformations to f, you're going to get g. Okay, so that's one of the transformations, and that's another transformation. So what this thing is this is a translation, that's what they called it earlier, or a shift of -3. But in reality, it just means the x's move 3 to the left. That's what that means. Every x is going to go 3 to the left. That's what this means. So for example, this point is now going to be over here. Now, the minus this thing is a vertical translation. Down 4. So now I go to that point, 1, 2, 3, 4. So that's the new point. Okay, that's this point right here. Now let's tackle this one. Over 3, 1, 2, 3. Everybody does the same thing. 3, 1, 2, 3, 1, 2, 3, 4. And then you just draw a line. I'm going to do this one. 1, 2, 3, 1, 2, 3, 4. I'm going to make it look like that. Then 1, 2, 3, 1, 2, 3, 4. So this is G, and this is F. All right. Okay, more examples there. Okay, so these could be a lot more tricky when you get this. Okay, so you have k of x is equal to negative h of 2x plus 1. Okay, I always attack this part first, anything that's in here. So now, all x's on h will be half of that x on k. So the new graph's gonna like kind of shrink. That's what that part does. Now let's take care of this next. This minus sign. The minus sign is going to reflect over the x-axis. That's the first thing. This is the second thing. Now the third thing is the plus 1. Third thing is this. So I'm going to take half the x, reflect it over the y, and then we're going to go the y up 1. And the reflect would be like the whole point, wherever you're at. It's really the y. Okay, so if I was at -4, now I have to take half of that. So half of -4 equals -2. So my new x is going to be that. Now to define the y, I take this y. Remember, this is -4, -3. I reflect it. Okay, but so I'm going to reflect it, which would be 1, 2, 3, which is here. So I took care of the x. Now I need to flip the y. The y is at -3, so it's going to flip to 3. But you're not over here anymore. You're over here now. You're at -2. And now the last one, up 1. So we're going to go up 1y to 4. So this point here is now over here. And you don't have to do it for all the parts, but you should do. You really need to do. If you're going to do this, I'm not going to do the whole thing, but you need to do this one. You need to do this one. You need to do that space. You need to do that one, and you need to do this. You'd have to do all these. Okay. I'll do the second one. I'm going to rotate this one right. Let me change the color. I'm going to do the transformation of that point, which is -2, 1. Okay, so I do the same thing, -2. I'm doing number 1. Take half that, which is -1. Now my new x is going to be here. Now I'm at 1. Now I need to flip this over to here. So now I'm here. Now I go up 1. So I took half of -2. I flipped the 1 to the -1, which is here, and then I added 1. Then you draw a line. So that's the first transformation. That's the first one. Okay, half of 0, 0. Flip, add 1. That's the third one. So you could get fast when you get good at it. Okay, -1. Take half of, sorry, this y is -4. Take half of that. We're here. Flip it. That's that point. I'm just literally doing the transformation. You could go back and go slower. Now I have to do 2. I have to do, that's a 4, and that's a 2. Take half of 4. I'm here at 2. Now I'm at 2. I'm going to flip to -1. I'm going to go up 1. So that's actually a hole. That's a hole. And the last one, I'm at 6, go to 3, flip, go to -4, go up 1, not supposed to go through the hole, but so this is your answer. Okay, those could be kind of tricky, so take some time and really make sure that you understand what I'm doing there. You could rewind and do the video a few times. Okay, so from the domain, the range of G, okay, it's a different question. Let's take a look at this. So you have F, so you need to transform this, and that's the range. Find the domain and range of G. Okay, this seems pretty tricky, but it's not too bad. Okay, just know this affects the x's, this affects the y's, and this affects the y's. So, and this is F. This is F, and this is F. So what you need to do is you need to transform this. Okay, so when you see a +3, that means all the x's go left 3. If there's ever anything inside the parentheses, if there's anything inside here, it's always against. It's the opposite of what you think you should do. If it's outside, if there's something here, or if there's something here, this and this, it's always what you think you should do, to the y's, not to the x's. So I see this x + 3, I'm like, okay, -3. Okay, if that's -3, then I need to go to -6. Now I'm doing G. Okay, this is an x. This is the domain. The domain are the x's. What do I need to do with that? -3. It's literally it. -3. 5 minus 3 is 2, so that's your answer. Now, what's the transformation to the y's? Always do the times first. So that's 2 times the y, and then minus 4 for the y. So it's 2 times the y, and then take away 4. That's the transformation. Okay? So here's your y's, because it's the range. The range is your y's. So 2 times 1 minus 4. So negative 2 y. I need to transform that. Okay, 2 times that, which is 6. 2 times 3, and then minus 4. So 6 minus 4 is 2. Literally, that's how you do it. Okay, go back, erase it, try it on your own. See if you could get it based off the transformation. Okay, this problem here, these are actually easier than the whole thing that we were doing. You could read through the problem, pause and read through the problem. This is H. We don't have H. This is P. We have P. This is P. Okay, so you would never do, there's really 2 ways to do a problem like this. You would never probably do it this way, the way I'm showing you now. This is H of X. You could do the transformations. For example, this is 3P to the 2X minus 1. You'd be like, okay, what does this do? Who does this affect? This affects your x's. How does it affect your x's? The new x's are half of what they were. So then I could just come here. Okay, well, what's half of that? Negative 1. What's half of that? 0 divided by 2? That's 0. What's half of that? 1. What's half of that? 2. What's half of that? 3. Okay, there we go. Now, what's the 3 and the minus thing do? Okay, to the y's, because this goes to the y's and this goes to the y's. So that's going to be 3 times the y minus the 1. Okay, 3 times that y. 3 times 1 minus 1. 3 times 1 is 3. 3 minus 1 is 2. So over here you have a 2. Okay, now I have to do it to this y. 3 times negative 1 minus 1. That's negative 3 minus 1. That's negative 4. Okay, let me erase these. You could always rewind this thing and go back and look. Okay, what's my transformation? 3 times, now I'm doing this one. 3 times 0 minus 1. So this is a minus 1. I'm doing this one. 3 times 3 minus 1. That's 8. This is, now I'm doing this one. 3 times 7 minus 1. That's 21 minus 1. That's 20. Now if you do that, if you do this first, now they say, what's h of negative 1? Oh, here's the input. Oh, that's 2. What's h of 2? Oh, that's 8. What's h of 0? Oh, h of 0? Oh, that's negative 4. Okay, but generally we don't really want to do that transformation. Generally, this is how you would do it. You do like this. Okay, well, h of negative 1. And I got to clean this table up. If you like that way that I just did it and you're good at the transformations, feel free to do it. You could do it. It just takes a little bit longer to do this method that I just did. But a lot of mistakes happen with the way I'm about to do it. So, okay, so you have this negative 1. So you put the negative 1 and you're like 3p to the 2, and there's an open parentheses, and I need to put that negative 1 in there, minus 1. So look what I did. I put this negative 1 into the x, into this x. Now I say, okay, 3p to the negative 2 minus 1. Okay, so this part of it is a function. This is your input. This is your input for p. So you go look, oh, well, here's p. What's my input for negative 2? That's my input negative 2. Sorry, what's my output when my input's negative 2? Oh, my input's negative 2. Oh, that's my output's 1. So that's 3 times 1 minus 1, which is 2. Okay? So essentially, it's just a different way to do the transformation. So I say h of 2. Okay. Well, remember, what does h equal to? H equals to this mess over here. So I say 3 times p of 2 That's where my x was. I'm going to put 2 in for x. That used to be an x. Minus 1. So that's 3 times p of 4 minus 1. Well, this is a function. That's not 3 times p times 4. That's p of 4. So you say, okay, well, here's my p. 4 is your input. That's my input. What's my output? Oh, my output is 3. So it's 3 times 3 minus 1, which is 8. Okay? And we don't have to do the last one. You guys could do the last one. If you do it that method, you should get a negative 4. So pick a way. Get your transformation and transform everybody, or do it the way that I just showed you. You take your pick. Okay. Now we have to describe the we have to come up with a formula based off a transformation. Okay, remember, translations is like a plus or a minus. Dilations is a times or a division. Okay, so anything inside is something that has to do with horizontal, because those are your x's. Anything here, or anything here, these are vertical. These are vertical. With a little practice, this stuff's pretty straightforward. So we need to transform f to get g. So we have this a, which is something with a vertical. We have f. B is something with a horizontal, plus c. Okay, so what do we have here? Horizontal dilation by a factor of 3. That's the trickiest one. Okay, so look what I'm going to do. If it's a dilation of 3, then that needs to be a 1/3. It always flips. It always goes against when you're working backwards. Okay? And there's a plus 3 out here. Okay, a vertical dilation of 4. If it's outside, it goes with your intuition. This is going to be a little tricky at first. A vertical translation of -7. So anything with the verticals on the outside. Dilations go here. Translations go here. That's literally your answer. That's what g of x equals. Okay? The trickiest one is this one right here. It always goes against your intuition. Even if you're shifting, if you're translating too. I must have missed a problem somewhere. Okay, did the domain. I probably missed a problem somewhere. Okay, maybe not. Okay, I'm back. You will get a problem like this. They'll say, it's not here, but it'll say something like find a k such that this will show up on your homework. Such that h of k gives you. I hope this thing's going to work out. Okay, sorry about that. Let's say 8/3. I had to kind of figure out where it was going to work. So we have to find a value k that you could plug in that'll give you an h of 1/3. So this is sort of tricky. So what you want to do is you want to say h of k equals, you're going to write the other part, the transformation. You're going to put a k into that transformation, into the x, minus 1, and then you're going to equal to 8/3. And what you're going to do is you're trying to find a k that when you plug into here, you could do all this work and end up with 8/3. So what you want to do is solve for this thing. And you might have to come back and look at this part of the video. Solve for this part. So to solve for this part, we need to add 1, add 1 over, and then times 3. So let's try that. I'll go over here. 3p of 2k equals 8 over third, okay, plus 1. And whenever you're dealing with fractions and you get a plus 1, generally you want to get like denominators, so I'll put a 3 here and a 3 here. So now I have 3p to the 2k, and on the homework they'll all come out to be nice and easy. Hopefully this thing works. It doesn't look like it's going to work. 11 over 9. I thought I had it working, but okay, sorry, I'm back now. This will make sense now. So I'll say find a case such that 3 times p times 2k, sorry, go back here. Okay, find a case such that h of k equals to 20. Okay, so you're trying to find a number you could plug in here to make it 20. Okay, so what you do is you plug k into here. You plug k into here, and then set this whole thing equal to 20. And then it should work. So 3p to the 2k minus 1 equals 20. Now, add the 1, add the 1. Cancel, so now I have 3p to the 2k equals 21. Now divide the 3 and divide the 3, and now it's going to be p to the 2k equals 7. Now you say, well, okay, this is an input, 2k is the input, and 7 is the output. Okay, for p. Here's my p. What's the output? My output's 7. What was the input? 6. What's my input? 2k. So you have to say 2k equals 6. What's the k? What's the number that you can multiply to the 2 and get 6? So your final answer is k equals 3. Okay? It's basically working backwards from your transformation. So we did this problem earlier in the lesson, and the transformation of the y's is 3 times the y minus 1. Okay, 3 times the y minus 1. So if you look at this point, okay, what was the transformation of the x? The transformation of the x was half of the x. So this point here after the transformation would be 2, and then 3 times 3 minus 1, so that would be 2 and 8. So if I said something like h of k gets me to 8, okay? Well, what's the k that gets me to 8? So then what you'd have to do is you'd have to go 3p of 2, put the k in for x, minus 1 equals 8. Okay, add the 1 over, so that's 3p to the 2k equals 9. Divide the 3, divide the 3. This is going to be p to the 2k equals 3. This is your y. Oh, I got a y there. What was the input? Oh, the input for that y, this needs to be 4. This right here needs to be a 4. So 2 times what gets me to 4? What's the k that could make this into 4? Oh, 2. So this answer, k, would be equal to 2. See? So you're just working backwards. So, all right, so that's 1.12. Let's go to 1.13. Now, this idea is called modeling. It's a major component of AP Pre-Calculus, and we're going to be doing this stuff a lot throughout the year. So you're going to build a model, a regression model, using your calculator. So to be honest, all you have to do is be kind of good at using this calculator. Here they're showing you the steps. They're showing you the steps of how to put the data in. This is how you enter the data. Okay, so I have my calculator here. I can say, okay, the way you do it is you hit the stat button and then the enter button in the bottom right. And then here's where you enter the data. So if you want to clear a data set out, you just hit clear and down. So we're going to get a data set and put it in. And then we're going to build the model. The computer just builds the model. It's very straightforward. Okay, so we're going to build a linear model. I'm going to show you how to do it. Select the desired regression model. Now that's going to be something you kind of have to get good at, but I'll kind of explain it here because the hardest part's knowing which model to pick. All right, so here's your data. So we're doing the age in weeks and the weight, age in weeks in kilograms. So you probably know that these are 5 randomly selected babies. Most likely the weight's getting bigger when the baby's getting older. So I expect some sort of increase. So every dot is a baby. Okay, every dot is a baby. The X represents the age, and then the Y represents the weight. Every dot represents a baby. So this would be an old baby that doesn't weigh a lot. This would be a young baby that weighs a lot. Okay, but for the most part, everybody kind of follows the trend, hopefully. So what can we do? We could put the data in our calculator. Put the data in our calculator, and then we're going to have the computer build the equation. So this is what we're doing, just so you have an idea. If it follows like a linear trend means that the dots are kind of raising at the same rate. The slopes are relatively the same. So for every 1 week, the weight's increasing roughly the same. So this line goes through it. So this is a linear equation. So linear meaning like y equals mx plus b. But for some reason, this stuff's built in stat. And stat people don't like being like the algebra people, so they write a plus bx. So that's what we're going to be attacking. If it's linear. Most likely it is going to be linear though. Okay, so this is what you do. I need to put this data in my calculator. Okay, so pull up my calculator. Okay, so for my X list, I'm going to put in the ages. So this is the ages in weeks. So 4, you just put the data in, put it, and hit enter. 5, 6 weeks, 8 weeks, 12 weeks. Now, next to that, this represents the weight of that baby in kilograms. Okay, don't mix the weights, and it's important that the 4.4 goes with the 5. Oops, I already have the 12 in. 5.7. So I'll just do a quick little double check. 5, 7, 5, 1, 4, 8, 4, 4, 4, 2, 4, 5, 6, 8, 12. Okay, perfect. Now, all these things are going to be in your notes. But the first thing you might want to do, let me see if they have making a scatter plot. I got to teach you, if they tell you it's linear, write the equation for a linear, then we know it's linear. But what I do is I always make a scatter plot. So follow these steps. I hit second, y equals. Well, first of all, make sure there's nothing in your y equals. This would mess me up. So make sure there's nothing in your regular y equals. So y equals, clear this stuff out. Now do second y equals. Okay, there's 3 plots. I only want 1 plot on. So I want this plot on and these 2 plot off. I want plot 2 and plot 3 off. Don't worry about 4 and 5. 1 needs to be on. So if you were off, most people are going to it like this. They're just off. You go into it, hit enter on the on button. See, now it's blinking on the on and it's highlighted. Come down here. These are the 6 graphs. The scatter plot's the first one. So hit enter on the first one. Make sure that's your X data, that's your Y data. You can see them, look where my cursor's at. You can see L1, so second L1, second L2. Okay, now this is something that you might not know. This is zoom 9. Okay, so that looks pretty linear. So as they're getting older, they tend to weigh more. Okay, so now this part's all in your notes. We want to get the equation for this. We want to get the equation. So you hit the stat button, and this is in your notes. Go to calc and go to number 8. Scroll down, or you could hit the 8. A plus bx. You click that. There is some tips about story Q. I don't want to do that. This is it. You might not see your R squared and R. Don't worry about that. You need the A and the B. You need the A and the B. So that's going to be, see, this A goes into that A, this B goes into that B, and you're pretty much done. So write the equation. Let's write the equation. So it's y equals, I have to look at it again, 3.545, 3.4, yeah, bad memory. Okay, 545. 545, and then plus 0.185x. 0.185x. Now remember, the x's are your age, and your y is your weight. Okay? Because basically, after you find the model, they're just going to say predict the weight for a baby that's this many weeks old. I mean, that's how they're all going to work. Okay, so they wanted me to write this here. They have a couple tips, and I'm not going to worry about those tips too much. So 3.545 plus 0.18. That's your age, and that's your weight. Use the linear model for what is the predicted weight in kilograms of a baby that's 10 weeks old? Okay, take a second. Where do you think I'm going to put this 10 to predict the weight? So it's going to go right into here. So this is the work that you would need. 3.545 plus 0.185 times 10. You'd have to show that. You'd have to show this whole thing to get credit for work. So I just come over here, and there are some shortcuts you could take, and to be honest, I'm not going to spend a lot of time on the shortcuts. Okay, I'm just going to show you how to do it, because I just don't think it's good sometimes to take too many shortcuts. I just put 10 in there. Okay, so 5.395. Now you have to look to see what units we were in, because I forget what units. Okay, kilograms. So that's it. Okay, the weight of the sixth baby. The weight of the sixth baby is 5.3. Use the model from part A. What is the age in weeks? Okay, so this is just working backwards. So it's like this: y, which is your weight, equals 3.545 plus 0.185 times x, where x is the age. So this question says the weight of the sixth baby is this. So they gave you the weight. Plug that here. 5.3 equals 3.545. I plug the weight where the weight goes. 0.185. And it's asking, what's the age? So now I just back solve for the age. So it's going to be 5.3 minus 3.545. I just subtracted that over. And then equals 0.185 times x. Now I just divide this. So my age is going to be 5.3 minus, you can pull this up and do it. So 5.3 minus 3.545 545. Make sure you hit enter, then divide it by 0.185. So they got the age about 9.5 weeks. Actually, let me not do that because these people are they're kind of picky. 9.486. 9.8486 weeks. Okay, so that's how you do a linear regression. So the more you do with these things, the better you're going to get. I'm going to skip example 3 just because I'm going to show you a different one. Okay, so you have linear, you have quadratic, and you have cubic. You can read through the last example to get an idea, but generally what I do is I'm looking for like, once I make the scatter plot, hey, is this thing going like straight up? Does this thing look like a parabola? Cubic goes like this, but we'd have to look. It's probably not going to be on the negative side, so a cubic might be like something goes up real fast, like x to the cubed. Okay, so input 1, output 1, input 2, output 8, input 3, 27. See how fast it's increasing? 4, 64. 5, 125. These are all the cubes. So the x's aren't going up fast, but these y's are going up really fast. Okay? So sometimes it is a little bit harder to tell between a quadratic and a cubic, but you just have to kind of play with these things and see what you're getting. So what I'm going to do is pull my calculator up. I'm going to enter the data. If you forgot, it's stat enter. Just clear my old data out. Okay, so 0.4.9. Just going to pause and come back. Okay, I'm back. I put the data in and I verified it. And I could just kind of see that these x's are increasing. This does look like increase and then back and decrease. So this does look like it's probably going to be a quadratic, but just to check, second y equals. Make sure your plot 1's on, plot 2, 3 off, scatter plot's on. And the way that you graph in statistics, you don't hit the graph button. See how that doesn't do anything for me? You hit zoom and the 9 button. Okay, what does this look like? This looks like a quadratic. So whenever you hit stat, whenever you find your equation, you hit stat and go over to calc. And you just take a look at these. So linear, quadratic, cubic, quartic, another linear, natural log or log mean the same thing. Exponential, power, logistic, sine reg, manual fit. So these are all the models that you could build with this thing. You just have to find out the right model. Well, this is a quadratic. So I click quadratic. So it's going to tell you the form. A quadratic is like ax squared plus bx plus c. Make sure your lists are right and calculate. Okay, so they tell you the form of the model. There's the form of the model. Which function? Well, your scatter plot looked like this. You got a single max. You have a single max. This is a quadratic. The scatter plot looks like a quadratic. Write the equation. Oh, okay. Well, here's your model. This is what you learned in algebra. Ax squared plus bx plus c. That's what it looks like. Anything that in this form is a quadratic. So then you're like, okay, what's my a? Negative 4.88883. I think this thing's going to disappear on me every time. Take a picture of it. Okay, so this is going to be y equals negative 4.883 x squared plus my b is 15.958, 15.958. Remember, always round to 3 decimals, x plus 4.996. So that's your equation. Okay, so that's how you would model a quadratic. All right, maybe work on that. Do it a few times. Do the linear and do the quadratic a few times just to make sure you're comfortable with the calculator buttons. Okay, so a residual is an actual minus a predicted. So please make sure. I mean, to me, this is a simple concept, but students tend to mess it up. It's the actual value. When they say value, they're talking the y minus the predicted value. How do you get the predicted? You plug the x they want in the model. Whatever comes out is your prediction. The output is your prediction. Okay, what's the actual value? This was data that was collected. So we know this already. There's no calculation. See, all these are all your actual y's. How do you know? Because we weighed them. That's the real data. Those are your actual values. Okay, so let me show you how to find a residual. Super straightforward. Using the model from example 1, what is the residual of a baby that is 5 weeks old? Okay, so interpret the meaning of the value in the context to this question. Okay, so a baby that was 5 weeks old, it's right here, they weighed 4.4 kilograms. And then, well, how do we get the predicted? The predicted, we have to use that equation, which I forgot. I'm going to pause it and I'll be right back. Okay, I'm back. I had to actually literally go put this data back in. So I put the data back in and I got 3 point, the y-intercept is 3.545 plus 0.185 times, okay, remember I'm trying to predict the value that's 5, so I put the 5 in here. Okay, so we might have did this one earlier, but I can't recall the number. So 3.545 plus 0.185 times 5. Now this is not the actual baby's weight. This is the predicted weight. This is what the model is predicting based off the data. So that baby was predicted to be 4.47 kilograms, if I didn't make a mistake. Okay, now what's the residual? 4.4, which is the actual, minus 4.47, which is the predicted, which comes out to be, I believe, negative 0.07, but I will double check it just to make sure. Okay, so the interpretation means is the actual weight for this 5-week-old is 0.07 kilograms below what the model predicted. So what happens is on the graph, it's like 1, 2, 3, 4, 5. So that was like the data, and then the line that went through it went like this. So at 5, the actual was 4.4, and then the predicted was on the line was 4.47. So any dot that falls below the least square regression line is going to have a negative residual. These are all negative residuals. It's sort of just basic math, these residuals, but they do give students some trouble sometimes. So make sure that you practice them. Make sure you practice them. With practice, this stuff is all pretty easy. And that's it. So hopefully you all made it through the end, and appreciate the hard work you all been putting in this year. So thank you.